Hello viewers, in today's class we are going to learn how to integrate a function of this form, right? So in our earlier video we have discussed the method how to integrate a function of this type e raised to x multiplied sine bx, right? Now in this lecture we are going to learn the method how to integrate a function of this type e raised to ax multiplied by cos bx, right? Okay, so now let us start. So let us denote this integral as I. So here this integral is of this form, and if we compare this integrand with this integrand, then the value of a is minus 1 and the value of b is 1, right? Now if we look at this function, then we see that this is a product of two functions. The first one is e raised to minus x and the other is cos x. Clear? Now we can integrate this function with the help of integration by parts, right? But here we are not going to use the method of parts. Instead we'll make use of the famous Euler's formula, right? And the Euler's formula, it says that e raised to I mx is equal to cos mx plus iota sine mx, right? So here we can use I for iota, and e raised to iota mx is equal to cos mx plus iota sine mx. So let us apply this rule to integrate this function. Clear? Now cos x, now if we use this formula and if we take m is equal to 1 here, then we see that e raised to iota x, because we are taking m is equal to 1, so e raised to iota x can be written as cos x plus iota sine x. Clear? And cos x is the real part of this complex number, right? So we can write cos x is equal to a real part. For real we are using the word re, so the real part of e raised to iota x. Clear? Now for cosine x, here we can write this expression. So the integral I can now be written as e raised to minus x multiplied by the real part of e raised to iota x, and here we have dx. Clear? Now this integral can also be written as a real part of integral of e raised to minus x multiplied e raised to iota x dx. Clear? Now by making use of the properties of exponential function, that is e raised to x multiplied e raised to y is equal to e raised to x plus y. So here these two exponential functions can be combined, and we can write e raised to minus x plus iota x dx due to this property. Clear? Okay, now we can write real part of integral of e raised to minus 1 plus iota, and here we have x dx. Clear? Okay, now minus 1 plus iota is a complex number, and we know that the integral of e raised to ax is equal to e raised to ax divided by a, right? So for a we have minus 1 plus iota, so we can write a real part of the integral of e raised to ax can now be written with the help of this rule. So we have e raised to minus 1 plus iota x over minus 1 plus iota, right? Now I can be written as, the integral I can be written as a real part of e raised to minus 1 plus iota x, e raised to minus 1 plus iota x divided by minus 1 plus iota, and we can multiply the numerator and denominator by the conjugate of minus 1 plus iota, and the conjugate of minus 1 plus iota is minus 1 minus iota, right? So here also we'll have minus 1 minus iota, right? Okay, now we can simplify it. So we have real part of e raised to, now this expression e raised to minus 1 plus iota x can be written as e raised to minus x multiplied e raised to iota x, and multiplied, here we have minus 1 plus minus 1 minus iota, and in the denominator we have minus 1 square minus iota square, right? And iota square is minus 1, so here we have minus 1, so this becomes plus 1. Here also we have plus 1, so we have a real part of e raised to minus x, and for e raised to iota x we can write cos x plus iota sin x multiplied minus 1 minus iota, right? And divided by 2, right? Because minus 1 square is 1 and iota square is minus 1, so we have 1 minus minus plus, so we have 2, right? If we multiply these two complex numbers, then we have the value of I as real part of e raised to minus x divided by 2, and let us multiply cos x plus iota sin x with minus 1 minus iota, so we'll get minus cos x, then we have minus iota cos x, and then we'll have minus iota sin x, and iota sin x multiplied by minus iota is minus iota square sin x, and that is plus sin x, right? Okay, because iota square is equal to minus 1, right? So let us now rewrite this expression as real part of e raised to minus x over 2, and let us express this expression in the form of a plus iota b. So we can write it as minus cos x plus sin x plus iota times minus cos x and minus sin x, right? Okay, so now if we take the real part of this complex number, because this complex number is of the form a plus iota b, then the real part is e raised to minus x over 2 and minus cos x plus sin x, right? So this is the required integral of this function, and here we should add the constant of integration as c.